There we go. So let's try another one of these. This will be. So I looked through all the mixture. They're all exactly the same, except for that one that we started. So let's just do a whole bunch more that are just like the one we did. Let's do at least two more, to make sure you're really, really comfortable, because they really are the same as that, except for that one. There's one weird one.
There won't be any cashew peanut type on the test?
I don't think so.
Okay.
Yeah.
The number 12 is a little wonky too.
Right, we can get there. But the setup's still going to be the same. All right, so we have 40% going to mix with 400 ounces of 70% to get 50%. So we're mixing different things, some 40% with 400 ounces. Mix with, I should say. There we go. So you know the deal, right? So when you get these mixture ones, you got the 3 beakers.
So the 400 ounces goes with the 40% or
No, 40% mixed with 400 ounces, I should say, of 70%. Yeah, good question. Yeah, they'll always tell you in the words which one it goes with. So from 40% mixed with 400 ounces of 70% to get some 50%. So see if you can fill that stuff in, and then multiply the top and bottom in the beakers to get the equation. All right, so we put the percentages in the bottom: 40%, 70%, 50%. Put the percentages in the bottom. Remember, the first two add. Notice there's a plus sign between the first two and an equal sign, because we're adding up, we're combining the first two to equal the final product, the mix, right? The one on the right is the mixture, isn't it? The other two combine to be that one. Okay. And now, what are the amounts in the top? Well, they only give you one amount. They always just give you one of the top 3. And they'll tell you which one. There it is. It's the 400 of the 70%. So it's not always in the middle. They will change that up. Sometimes they'll go right, or left. Sometimes they'll put it on your left, and sometimes they'll do fancier things than that. But it's usually going to be one of those first two. The only weird one, the nut problem that we started and skipped, and we'll come back to that. That one they gave you the mixture amount. That's different. But on all the rest of the problems, they're going to give you one of these two, the number above one of these two, and the other one's just X. That makes sense? Whichever two, and they'll tell you, you don't have to guess. They're saying 400 ounces of the 70%. So you know it goes above the 70%. And then the other one is always just X. And then what is this top up here? You just add them up. Yeah, X plus 400. And now how do we get our equation? You multiply top and bottom. So multiply these two. 40X, multiply these two. 70 times 400, multiply these two, 50 times X plus 400. Good like that? Multiply. All right, and then work it out, which you guys are pros at now. So that's 70 times 400. What is that? 28,000, huh? And 50 goes through here. 50X, and this is 20,000. These are big numbers. Here's the wall. X is saying I want to be alone. What do we do with X's on opposite sides? Get rid of the lower one. The lower one's the 40X. Subtract 40X from both sides. And we've got 28. These are gone. 28,000 equals 10X plus 20,000. X is still saying I want to be alone. So subtract the 20,000 from both sides, and we get what? 10X equals, what's this, 8,000? 10X equals 8,000, all right? And so let me bring that where I have some space. So I'll go 8,000 is 10X, put a wall here. Bring it up here, and then divide by 10. Last step, 800. X is 800. Now, what do you do when you got that X is 800? Put it in back in the original. The mystery's over. Everywhere you've got X, the mystery's over. Now we know X is 800. X is 800. So we can answer any question they want to ask us now. 800 is how much 40% stuff. 400 is how much 70% stuff. We knew that from the beginning. And 800 plus 400, which is 1200, is how much 50% mixture we create in the end. Once you got X, you got everything. Huh? Just plug that in for X everywhere. The mystery's over. Good on that? Does that make sense? You guys are lean, mean mixture machines now? Yeah, let's go to number 12 here. Okay, let's try this one. So, pharmacist mixing, wishes to mix. Okay. Can you all read those words up there? Is that okay? I don't really want to write all those out. So 3 beakers. So they're being a little subtle on this one. Let me give you a chance to kind of read it careful.
Can we do the number 12 up to this one?
Mm-hmm. Is that the water one?
Yeah, that's one I got.
Right? Water has 0% acid or whatever they're talking about. That's all you need to hear, huh, Alex? Yeah. Just go back and do 0%. Everything else is the same. When you add water, you add 0% whatever.
So it's 0
Just another beaker will have 0%. Yeah, and X above it. Yeah, that's right. And then number 13 will be pure, like antifreeze or whatever. Pure is what percent? If it's pure, it's 100%. Number 13.
But then I went to show an example, and they're looking at the percentage of alcohol, of purity, of,
They did something weird? Don't pay attention to them if they do something weird.
they do something really weird.
Water 0%, pure is 100%. Do the rest the same. Everything else the same. All right, so now on this one, they're trying to be a little tricky with the percentages. They say the pharmacist wishes to mix a solution that is 4%.
That's a mixture.
That's the mixture. That's over here. You see, they're being a little subtle, aren't they? That's the final desired mix. That's what the pharmacist wants to make. So that goes over here, huh? You see that? So put the other ones in there. Can y'all read that? It's 80 milliliters of 2% and with some 6%. So 80 milliliters of 2% with some 6%.
Does the one that has like the 80 milliliters and 2%, does it have to be in the middle, or?
It doesn't matter. The two on the left are either order.
Oh.
Yeah, either order. Yeah, the first two can be put in either order, but the mixture one must be on the right side. Did it come out?
Yeah.
Yeah, that's all you gotta do. You should have thought of that, Alex. This makes sense. I'll go 80 milliliters of 2%, and then get the 6%. You could swap those left two, it doesn't matter. But the 80 has to go above the 2%, wherever you have it, doesn't it? Doesn't really matter where you have it. And what do you do with the other blank? X, right? The other blank is X, like normal. And then what is this up here? 80 plus X, or X plus 80, doesn't matter. The order, remember, of adding never matters. Does that make sense? Now it's just regular. good? So how do we get the equation? We multiply, huh? Multiply top and bottom. So multiply these two, that'd be 2 times 80. Multiply these two, 6 times x. Multiply these two, 4 times 80 plus x. Remember, we got to put parentheses around the two things added there, right? Because that way we're multiplying them, the whole thing. So, by the way, let me stop for just a second. Why is it I'm saying it's okay to skip the decimals? Right? Jeremy asked that a long time ago. It's a really good question. Shouldn't this be 0.02? Don't write this down. But shouldn't that be 0.02 and that's 0.06, right? When percentages become decimals, haven't we learned it goes back 2 places? And that matters, right? It does. That's true. And that should be 0.04. That's true. That's true. That's true. It should be technically. But I could get rid of it because those decimals are on both sides of the equation. Remember, when something is on both sides of the equation, you can do the same thing to both sides, and if they were equal before and you treat them the same, they'll still be equal afterwards. Well, do you see what? Don't write any of this down. But what I could do is then I could multiply by 100. Well, what if I multiply that by 100 and this one and this one? It's okay because I'm doing both sides of the wall. I'm doing all the terms on the left side of the equal side, all the terms on the right side. I'm doing the same thing to both sides, so I'm preserving equality. If they were equal before, treat them the same, they'll still be equal. And when you multiply by 100, what does the decimal do? 2 places and goes back. 2 places and goes back. 2 places and goes back. So we skip the whole thing. That's why it's okay. Yeah, that's why it's okay to skip the whole thing and just leave those percentages as whole numbers. Because yes, technically they're decimals, but then you can just multiply through by 100 and turn them back into whole numbers because they're on both sides. Now careful, if you only have a decimal on one side of the equal sign and not on the other, then you need to make that decimal, that percentage into a decimal. You can't ignore it. It's only because they're with a mixture, they're on both sides. So I can skip the whole thing. Does that make sense? I didn't skip that, for example, when we did the money ones. Right? We left the decimals in there because they were often on only one side. I think. I don't know. But anyway, but mixture, they're on both sides. So that's why it's logically okay to just skip it, and it makes life a little easier. So let's do that. So this is 2, this is 6, this, in case you we're wondering why that's true. So 2 times 80 is 160, this is 6x, this multiplies 320 plus 4x, we get to there. Now, always do the x's first, right? Don't worry about the 160 and the 320, first do the x's. It's always first x's. X's on opposite sides, what do we do when we have x's on opposite sides? Smallest one, the 4x, from both sides, gonzo. And then we have 160 plus 2x is 320. X is saying I want to be alone. What do we do to get x alone? Minus the 160. And that's gonzo. So I'll bring it up to here. Now we have 2x, and this is going to be what, 160 again? Subtract, last step, divide by 2. X is 80. So mystery's over. You can put that 80 in everywhere you've got x. So that'd be right here and right here. 80 plus 80 is 160. So 160, whatever these are, grams, what are they? Milliliters. Milliliters of the 4% and 80 of the 6%. Is that good? Those comfortable? Those mixture ones getting easier and easier? Feel like you could do those on the practice test today and the real test tomorrow? Questions on that one? Did I say tomorrow? Monday, yes, I mean Monday. I keep saying tomorrow. Saturday.
You're more than welcome to go.
Yeah, but I might be alone. You might be alone. All right. So now these last two problems, they're going to try to be a little tricky, but you heard me talking about it with Alex, right? They're going to do water. On this one, they're going to say, let's just take some solution and dilute it by adding water. Well, if you think about it, that's really a mixture between water, which is 0% whatever you're talking about, acid, base, salt, whatever, coffee, whatever. It's got nothing in it. It's 0% whatever, plus the other one. So whenever they say water, you just say, oh, no problem. That's just a normal mixture problem, right? Here's the mix over here. And the water is just 0%. The rest of the problem is the same. The water just has no whatever. What are we talking about in this problem? No salt, no acid, no whatever. Yeah, this is alcohol. No alcohol in it. Water's got nothing but water in it. So it's got no alcohol. So it's 0% alcohol, the water is. Does that make sense? So whenever they give you a water problem and they're diluting something, you just say, oh, okay, that's just a 0% mixer. Can you do the rest the same? Is it 2? Are we getting 2?
Yeah, it's 2.
So 0 times x is 0, beautiful. 6 times 10 is 67x. Yeah. Oh, there's no x. Yes. Just 0%, 6%, 5%, no x. No, the x goes up here. Yeah, oh, you thought, oh, I see, yeah, right. Yes. Is it 2?
Yeah.
It's getting 2? Let's see, so 0%. The other one is 6%, and it even says 10 milliliters of 6%, doesn't it? So that's 10 over the 6%. And you want to get a concentration of 5%. You want to reduce it, right? Dilute it down to 5%. Is that good? And so what goes up here and what goes up there? So this one is always x, and over here goes x plus 10 because we're adding those together.
See, the reduce makes me want to subtract somewhere. The word reduce.
Yeah, no, we're just adding some 0%.
Okay.
So now we multiply top and bottom. Yeah, you reduce the percentage by adding. See, the problem is we're actually adding water, aren't we? So that's why we want to actually plus. You're just adding water to reduce the percentage. Okay, so we multiply top and bottom. What is 0 times x? That's just going to be 0. We can just skip it, really. Plus 6 times 10 and 5 times x plus 10. Yeah, this is just 0 gone, huh? 60 equals distribute 5x plus 50. Good to there so far? X is saying I want to be alone. Subtract the 50. 10 is 5x. Last step. Divide by 5. X is 2. So that means 2 is how many milliliters of water. Because remember, the x is how much 0% is how much water. We got it. So you can quickly, if you want to dilute something and figure out how much to make it happen, there you go. You could do that for your home mixing of little things, little cleaning solutions or whatever. I don't know. I never do it at home, but one could. If you take chemistry later, there you go. You'll be ready to go for the equations. Does that make sense how that works? And okay, can I flash off of that one? They're going to, instead of water, like the last problem, number 12 was water, this one they're going to say pure antifreeze. So instead of adding water, they're going to add pure antifreeze. So what if you're pure acid or pure alcohol or pure
100%?
100%? Does that make sense? So the last one we had water, which was 0%. This one we have pure. So whenever you add pure whatever, you're adding 100%. The rest is the same. See how these last two, they're trying to be tricky on it? They're just doing water. On the last problem, it was water, which is 0%. On this one, it's pure, which is 100%. The rest is the same. So we good on this one? So it says 4 quarts of 10% to get a 20% mix, huh? Like that? That good? So we know the deal, right? This is X up here, and this is X plus 4 there, right? How we always do that. And then we multiply. You guys got 0.5? Is that the answer you got? That's the right answer. Multiply top and bottom. So multiply, that'd be 100x, multiply 10 times 4, multiply 20 times x plus 4. Is that good? Multiply, multiply, multiply. And so this is 100x, this is 40, distribute, 20x plus 80, here's the wall. X is saying, I want to be alone. Remember, always x first. Don't mess with the 40 and the 80. X first. X first. So what do we do when we have x's on opposite sides? Get rid of the lower one, right? Get rid of the lower one, gonzo. And then we have 80x plus 40 is 80. And so now x is going to want to be alone, so subtract 40 from both sides. And I'm running out of space here. So I'll bring it over here, so I have 80x equals, and this is going to be 40, huh? 80x equals 40. Good to there. Last step as always, divide by whatever's next to x, identical twin. This will calculator tell you 0.5. So there's the answer, half of a whatever quart of pure antifreeze. Right, because that's x is how much pure antifreeze, isn't it? So half a quart of pure antifreeze must be added, 0.5. Good. All right. So look at the. This is the like this is the super hard. Just like we had one very different. What was it called? Value money problem. We have one very different mixture. Let me just do this quickly. We really need to get to our practice exam. So we're out of time. We can't do this one. No, I'm kidding. I'll do it real quick. Just trying to get out of it here. All right. So, yes, just the easy ones in class, please. Just the easy ones. All right. At the nut house. All right, pound cake. So it starts off the same. We put the money on the bottom, you know, like the percentages. 6, 3, and 550. All right, so I get the 6, the 3, and the 550. And then they're giving me one other number. It's 3 pounds, but it's over here. That's the new trick. They're putting it over there on the right side. You see that trickery? That's tricky. Instead of on one of the two on the left. And normally they always give us one of the two numbers on the left. And then it's just the other one's X and away we go, right? So this time they're not doing that. They're messing us up. All right. So we got to be tricky. You ready? So there's the normal part. Here comes the trickery. All right, so you got to be true. So I'm going to call this one X. That's what we always do. But the whole question is what goes there? What goes there?
Y.
Yeah, there is a way to do it with y. I just don't want to do the two letters. We're not covering that. Next class, I'll put a y there because we can handle two letters at that time. Yeah, this class I'm going to do it with only x. But there is a way with doing it y. In the next class, exactly what we'll do.
Is it the x plus 3?
Well, think with me this way. We need to put something here so that x plus whatever I put there will just equal 3, right? Because that 3 is the total, right? You know what I mean? They always add up, don't they? Let's look back. Let's look back. Like right here. X plus 4. X plus 4. They always do that, don't they? They have to add across the top. They don't add on the bottom. The bottom are just percentages. Those don't add. But the tops add. They're amounts, right? X plus 4. X plus 4. They have to add. The first top plus the second top has to equal the final top. They have to. They always do. So let's go back and look at it. What could I put here? X plus what will somehow just be 3. How could that happen?
3 less than x.
Yeah. Oh, no, almost. Not 3 less than x, but
3 subtracted from x.
Minus.
if I put x minus 3 is what you're saying.
Yeah.
It's not quite right. Because what you tell me, what would x plus x minus 3 be? 2x minus 3. That wouldn't be 3.
Minus. Minus
So
plus 3.
So what do you do?
Minus 3.
Minus x. Minus.
You got to get rid of the x, right? You got to lose, because over here there's no x in the final thing. So you got to lose the x,
Okay, minus.
and you got to get the 3. That's what you need. Do you see that'll work? You see, now when you add this and this, the x's go bye-bye,
Yeah.
and it's just 3. Do you see that trickery? That's tricky. That's the advanced problem. That's the A's separating from the B's there, right? That's the excellent student that can grab all that. You see that? See what happened there? That's trickery. See, I had to somehow put something that would make the x go away, so minus x, and would bring in the 3. So that's tricky. And like I was saying with Alina, in the next class we'll make that a y, x and y. We'll do problems with 2 letters. And so we'll do something different, but for now we're just going to do 1 letter, so that's how you have to do it if you're only going to use 1 letter. So the rest is pretty much normal. Do you know what I mean? Now we just multiply top and bottom. So multiply top and bottom, 6x. Top and bottom, 3 times 3 minus 6. Top and bottom, 3 times 550. Like that. 6x and distribute. 9 minus 3x. And this is 15, so that's 1650. Like that. Is that good? So 6x minus 3x.
How is it 1650?
3 times $5.50.
Oh, okay.
And then x is saying I won't be alone. So subtract the 9 from both sides. We get 3x equals whatever number that is. Was it 750? 750. Last step, divided by 3. 250. 2.50. So there we go. 2.5 pounds of whatever. So you can put the 2.5 now in for x. 2.5, 2.5. So this is 3 minus 2.5, which is just 0.5 pounds of the $3 stuff and 2.5 pounds of the $6 stuff.
Yeah, I followed that and it came out wrong.
Is that making sense? I think we need to get to our practice exam before time gets away from us. Take about 40 minutes or so on this thing.